Hi, this is Nemla Rednam. In this video, we are going to continue the topic factorization. In the previous video, we looked at factorizing a given algebraic expression by identifying the common factors. And the second method we looked at was when four terms are given to us, we try to group them, pair them up, and try to find the common factor in each pair. And then in the second step, we arrive at the factorization, that is writing the given algebraic expression as a product of factors. Now here in this exercise, we are trying to use the identities that we are already familiar with. Okay, so let us write down the identities first. If you remember, we already are familiar with the identities. A plus B whole square is equal to A square plus 2AB plus B square, and A minus B whole square is equal to A square minus 2AB plus B square. And then I have A plus B into A minus B is equal to A square minus B square. So this is how we have learned it. Now in factorization, we are going to do the other way around, right? Initially in algebraic expressions, we were given this and we expanded it using multiplication of two algebraic expressions, and we arrived at this, right? Now, if you see that you are given an algebraic expression that has three terms in it, then you will see whether the first and the last terms, that is A square and B square terms, if they happen to be perfect squares, then you will check if the middle term is 2AB. In fact, if it is 2AB, then we are going to directly write the given expression as A plus B whole square in case of plus over here, and A minus B whole square in case of minus over here. So that will give you your factorization, because A plus B whole square is simply A plus B into A plus B, which is nothing but product of factors, right? So that is how you are going to use the identities. So when the question is given to you, like this is similar to the, something that I've explained in the previous chapter as well. In the previous chapter also, you had two exercises, direct and inverse proportion, and you know that every problem in the first exercise is direct proportion, every problem in the second exercise is inverse proportion. Similarly, here the second exercise is using these identities. So what I would suggest is, for your practice, you pick up the questions at random, write them down in a notebook and then solve them, so that you start from scratch, because that is how it is going to be in the exam. You don't know which exercise it has come from. So one way of at least arriving or beginning, getting an idea of where to begin, is when you have three terms, then you have to make a guess that maybe we will be using the identities, right? The first two identities. Now that is about the first two. Now this identity A square minus B square is equal to A plus B into A minus B. So if the given expression has two terms and both the terms are perfect squares and they're separated by a minus sign, then you will be using this identity. Okay. Here I'm going to mention the other, this is identity as well, which we will be using, right? This is nothing but x square plus x into a plus b plus ab. So when you see an algebraic expression that has three terms, right, and what we are going to do is, I'll be able to explain this better with an example. The constant term, if you can write it as a product of two factors such that their sum is the coefficient of x, right, then you can write x here, right, their sum is the coefficient of x, then you can say that this is nothing but x plus a into x plus b. You will be understanding this better. You will be able to understand this better once we do the sums. So let's start the exercise. The first question in the exercise says factorize the following expressions. So like I said, it has three terms, so you have to guess that maybe the identities will be helpful, and you can see that this is a perfect square, right? So good, so far so good. This is a perfect square, so that's going to be helpful for me. And 16 is also a perfect square, right? So this is nothing but 16 is 4 square, and then you will check if the middle term is 2ab. So this is nothing but 2 into a, in this case a is a, and here b is 4. So you can see that this in fact is 2ab. Therefore I can simply directly write it as a plus 4 whole square, right? So you'll be mentioning the identity here and so on. Next, I have p square is a perfect square, 25 is a perfect square, right? Here I have minus. Now check the middle term, 2ab. 2 into 5 is 10. So it does fit the criteria, and because I have a minus sign for 2ab, I'm going to put minus, and that's it. That will give you your answer, right? Next, here I have 25m square is a perfect square, 5m whole square, and this is also a perfect square, 3 square. Now let us check the 2ab term. 2 into 5m into 3, is it 30m? Yes, this is 30m, therefore it fits the criteria, and I can directly write 5m plus 3 whole square, correct? Next I have, this is a perfect square, 7y, 6z, so I have to check 2ab term. 2 into 7y into 6z. So let me check. 7 into 2 is 14, 14 into 6 is 84. So it does match the 2ab term. Therefore, I am going to write it as 7y plus 6z whole square. So that is about the fourth bit. Then I have 4x square, which is 2x whole square, and this is again 2 square, and this, if you check, 2 into 2x into 2, it does fit the criteria, and I have a minus sign, so I'll write it as 2x minus 2 whole square, correct? The same thing can also be written as, in fact, because we are going to factorize it, you can see that 2x and 2 have common factor, which is 2. If I take it outside the bracket, it's going to look like this, right? And so I'm going to write it as 4 into x plus 1 whole square. Next I have 121b square, which is 11b whole square. This is 4c whole square, and this is 2 into 11b into 4c. You can quickly check that it does fit the criteria. Therefore, I have 11b minus 4c whole square is nothing but the given expression. Now here they have given us a hint. Now I have two terms, L plus M whole square and minus 4LM. Now clearly there is nothing common, and clearly your third identity is not going to work because this is not a perfect square. So it's not a square minus b square. So let's use the hint that they have given us. Expand L plus M whole square. Okay, it's going to give me this, right? Now you can see that these are like terms, therefore I can simplify it as minus 2LM. Plus 2 minus 4 is minus 2, right? And this is nothing but my identity, second identity, a minus b whole square, right? Now here, this is a perfect square, a square whole square. This is a perfect square, and this is nothing but the 2ab term, right? 2 into a square into b square. Therefore, a square plus b square whole square is my factorization. And you can see that I cannot factorize this any further. Therefore, that is the final answer. Now, let's look at the second question. Now, here you can see that you have two terms in each of these sums. Okay. So, let's look at the first sum. I have two terms and both the terms are perfect squares. Therefore, a plus b into a minus b, which is 2p plus 3q into 2p minus 3q. That's it. This is my factorization, right? Product of factors. Next, here you will see that although there are two terms, I have the numbers over here that the coefficients are not perfect squares. So I have a problem here. These are not perfect squares. How do you proceed further? What we will do is, if you can notice, 63 and 112 have a common factor 7. Correct? So if I take 7 outside the bracket, then I have 7 ones and 7 6. Correct? Now you can see that 9a square and 16b square are perfect squares, which are nothing but 3a plus 4b into 3a minus 4. That's it. So that is my factorization. Here again I have two perfect squares, perfect for me. I can quickly write down the factors, right? Next I have, Here you will see that 16 and 144 are good enough for me, 4 square and 12 square, right? But the problem is with x power 5 and x cube, these are not perfect squares. They have odd powers. That means I can't make a perfect square out of it. So let us again try to take whatever is common, we'll take it outside and then check. 16 can be taken outside, correct? X cube can be taken outside, okay? And what am I left with? I'm left with x square over here, right? And then 16 into 9 gives me 144. So minus 9. Okay. So I'm going to have 16x cube, and this I can write as x plus 3 into x minus 3. Right. So this is my factorization. I have a product of factors over here. So that is my final answer. Here you will see that I have two terms in the form of a square and b square. So let us proceed carefully. L plus m is my a plus b L minus m, correct? And then I have a minus b, which is a minus, and I have to be careful with the bracket here. Here I have 2L, right, into L plus m minus L plus m. Minus into minus becomes plus. So L gets cancelled. So I have 2L into 2m, which is nothing but 4LM. So here, before starting this topic factorization, it is advisable, strongly advisable, that you first go through algebraic expressions once that we have done earlier, because you need to be familiar with these algebraic expressions and try to understand however big or small the expression is, when is it in the algebraic expression form and when is it in the form of product of factors, and taking out the factors, opening the brackets, trying to factorize it. All these things you need to be comfortable with that. So it is strongly advisable that you go through the chapter algebraic expressions before you start this, right? So let's move on. Sixth question, I have 9x square y square, which is a perfect square, and 16 is also a perfect square. So 3xy plus 4 and 3xy minus 4. 3xy minus 4. 3xy minus 4. That's it. So that is my answer. Next I have, here again you will see that this is a perfect square. What about this? Okay, I have an expression which has 3 terms in it, and clearly it is very obvious that this is a minus b whole square. So let me first write it down. And now you will see that x minus y whole square is a perfect square. So this is now the third identity, a square minus b square, which is nothing but a plus b into a minus b. So that's my factorization, right? Next. Now here again you will see that there are too many terms. There are 4 terms here. So like in the earlier exercise, you can try to pair them up and check. But you will see that I have a perfect square here. This is also a perfect square. This is also a perfect square. And I have a BC term. BC term. So I'm going to try to club these 3 into a perfect square. Let us check if these 3 form a perfect square. Now this is 2b whole square. This is 7c whole square, right? Now what is 2 into 7 into 2? 28. Fits the criteria b into c. Therefore this must be a a minus b whole square format. So let us write it down. 25a square minus 2b minus 7c whole square. Now you will see that this is nothing but a square minus b square, which is a plus b into a minus b. So when I open the minus, minus 2b plus 7c is what we will get. Correct? So this is about the second sum in the exercise 12.2. Next we have factorize these. So here clearly you can see that this over here has only x common. So I'm going to take x outside the bracket, ax plus b. I cannot factorize this any further. Here you will see that only 7 is common between these two. There's nothing else which is common. So take it outside and leave the rest inside the bracket. Here you can see clearly 2 is common, 1x is common. So take that outside and whatever is inside, let us write that and then decide if it can further be factorized. You can see that x square plus y square plus z square cannot be factorized further. Now here I have 4 terms, so I'm going to try to pair them up, right? Here I have m square common. Here I have n square common. So a plus b and b plus a are nothing but the same. So take a plus b common. I'll have m square plus n square. That's it. This is my factorization. Next here, I'm going to pair them up. L is common and here 1 is common. So I have L plus 1 into m plus 1. That is my factorization. Here I have y plus z already factorized and given to me. So I'll take that common and y plus 9 is left inside the bracket. Here I have 4 terms again, right? So you can try pairing them up, right? Let us see if pairing works. Okay. So here I have 5y common, y minus 4, and here if I take minus 2z, okay, I have 4 minus y, right? So I'm going to take the minus sign inside the bracket. I'm going to write it as plus 2z into y minus 4. So here you can see that y minus 4 is common. So I have y minus 4 into 5y plus 2z. So that is the factorization. Here again I have 4 terms. So let us try pairing these up. If that doesn't work, we'll try something else. So 2a is common here. 5b looks like it's going to work, plus 2. And here only 1 is common, 5b plus 2. So then I'll write it as 2a plus 1 into 5b plus 2. Because now 5b plus 2 is the common factor. Right? Next, again I have 4 terms. Let's pair them up as it is given to us. I have 2 here and y here common. So 3x is left inside the bracket minus 2. Here I have 3 common. Okay, 2 minus 3x, right? So I have 3x minus 2 and 2 minus 3x. I don't want that. I want a common factor. So take minus outside the bracket and check. See, now this is common. So now I can write it as product of 2 factors. The factors being 2y minus 3 and 3x minus 2. So this is how we'll be solving sums of this sort, right? Next question, factorize the given expressions. So here I have a power 4 minus b power 4, both are perfect squares. So third identity is going to work. So I'm going to write it as a square plus b square, because a square is my a here, into a square minus b square, right? Now this can further be factorized. So this is going to be a plus b into a minus b into a square plus b square. So we'll leave it here because a square plus b square cannot be factorized further. So here again it's going in a similar manner. If you proceed, you're going to get 3 factors. P square plus 9 into p square minus 9. 9 square is 81, right? Now this is again a square minus b square because 9 is 3 square. So that can be written as p plus 3 into p minus 3. And then I have p square plus 9, which cannot be further factorized. Right. Now here I have x square plus y plus z whole square. This is my a plus b term into x square minus y plus z whole square. This is my a minus b term, right? Now what we are going to do is, we'll leave this as it is. This cannot be factorized. When it comes to this, this is again a plus a square minus b square, which is a plus b into a minus b. So I'm going to write it as A plus B into A minus B. When I open the bracket, minus goes to both x and y. Into, there's one more factor, I'm writing it down in the next line. It is x square plus y plus z whole square. So it is a product of 3 factors over here, 2 linear and 1 quadratic. Next I have x square plus x minus z whole square into x square minus x minus z whole square. Now you can see that this cannot be factorized further. I'm going to open the bracket. I'm going to get x square. So x square plus x square is 2x square, right? Minus 2xz, right? Plus z square. So this is the first factor. Now the second factor, when you open the bracket, x square and the first term here x square gets cancelled, right? And I have 2xz minus z square. Now here you will see that z is common. So I have to bring it outside the bracket. Okay, minus z into the third factor that we found, the quadratic one, plus z square. So that is your factorization for this sum, right? Next we have a power 4. So this is a minus b whole square. So a square is my a minus b square whole square, right? So this is what we have. Now you will see that this can be factorized, which is nothing but a plus b into a minus b, correct? Whole square means both of them have to be square. So this is your factorization, right? So next sum, you have this, we are using x plus a into x plus b whole into x plus b, the expansion of that. So you have 3 terms in the given question, and you will see that these 3 terms, there are no perfect squares. Like 8 is not a perfect square, p square is, but 8 is not a perfect square. So your identity, the first 2 identities are not going to work, right? So here what you will look at is the constant term. What we will do is look at the constant term, try to write it as product of 2 factors whose sum will give you the middle term, the linear term, right? You will understand in a moment why we are doing that. So if I write it as 1 into 8, 1 plus 8 is going to give me 9, which is not this. I have 6 here. Next you look at 2. 2 into 4. You will see that 2 plus 4 is 6. So this is a indication for you that this might work. What we will do is we'll split the middle term as 2p and 4p. Okay. So we're going to write this as p square plus 2p plus 4p plus 8. Now you have 4 terms. Now you can immediately see that if I pair them up, okay, I get p into p plus 2 plus 4 into p plus 2. Now again p plus 2 is common here. So p plus 2 into p plus 4, this is my factorization, right? So that is how you have to proceed. Now here in the second question also you will see that 21 is not a perfect square. So let us try to split the middle term. So 21, 1 into 21 is not going to work. I need minus 10. So if I check next factor is 3. 3 into 7. You will see that 3 plus 7 is 10. Okay. So I'm going to write this as q square minus 3q minus 7q plus 21. Now pair them up and see. I have q here into q minus 3 and here I have minus 7 outside. If I take it outside the bracket, I have q minus 3. Now I have q minus 7 into q minus 3. With enough practice, you will be able to directly write this step after you have realized what are those 2 factors that I have to consider, right? So you will consider this as minus 3 into minus 7 and directly write it as q minus 7 into q minus 3. Now here, The third question also, you will see that 16 can be written as 1 into 16 or 2 into 8. Now you will see that I have minus 16 here and I have a plus 6. So minus 2 into 8 is one way of writing minus 16, and you'll see that 8 minus 2 is nothing but plus 6. So you have to split it up as 8p and minus 2p. Okay, so I have p square plus 8p minus 2p minus 16. Now you will do your pairing up and then proceeding further. Minus 2 is common here, p plus 8. So here I have p plus 8 into p minus 2. So the symbol here, the sign plus or minus is also very important. Here I have minus 10, here I have plus 16. All these have to be looked into very carefully and you will be able to arrive at the answer, right? So like I mentioned earlier, taking the sums questions at random and practicing it is more useful from exam point of view, because in your textbook when you're solving, you know that this question is regarding first identity, this question is for second identity, so on, and similarly the exercises also. So that is what I would suggest. So with this we complete the second exercise of factorization. In the next video we will be looking at the third exercise.